Okay, now we're on to 3.6. I want you to think of this lesson as like a review of the whole chapter. So 3.6, it's called curve sketching. We're also putting in analyzing f prime and f double prime. So it's just kind of putting the whole chapter together. If you look at this first table, this is everything that you need to know. So look at it saying that f has y values. F prime tells you how the y values are changing, which is the slopes. And then F prime tells you how the slopes are changing, which measures concavity. So it goes through and walks you through everything. I'm not going to tell you everything. This is something for you to study off of. That would be really boring, but it is an awesome tool. For instance, look right here. If F prime is negative, right? So if I meet up here, it means the graph of F is decreasing. Okay, so it just walked you through everything. I would think you could cover up a square and maybe have someone quiz you, okay, and make sure that you have it all. What I'm going to do to start off this section is we are going to go through and analyze graphs. So what we're going to do is look at the first one. If I tell you that this is the graph of the function f, how can we answer these questions? And then I'm going to change it and say, what if we're not looking at f, and what if we're looking at f prime? Well, what does that do? Okay, so we're going to change the graph. That's why there's no labels on it as we go. So the first one, on what open intervals is f decreasing and concave down? Take a second and draw what is something that is decreasing and concave down. We should have something like that. Okay, so we're looking for that. This is the graph of f, so where does this happen? Do you guys see it happens right here? Decreasing, this is concave up, this is increasing, decreasing, and concave down. Okay, so right here and right here. So we're going from -7 to -5 and from 2 to 3. Okay, on to the next one. We need f increasing and concave down. Go ahead and try that. What would that look like? Something like this. So try to trace over the graph and see, well, we know it's not this piece because that's decreasing. This is increasing and concave up. Here we go, increasing and concave down. Okay, so what interval is that? That will be from -1 to 2. So the thing to note on this is they're asking about f and they give us f. This is going to be as easy as it gets. They're asking about something that we can see. Okay, inflection points. Inflection points are going to be where we change concavity. So if you look at this one, look, concave down and then concave up. Here's an inflection point. This is all concave up, but then it goes to concave down. So here's another one, -5 and -1. Then we have concave down and it switches to concave up. So we're looking at the numbers x equals -5, -1, and 3. Okay, now let's kick it up a notch. Instead of looking at f, now we're going to be looking, if you look here, it says f prime. Okay, the other one was f. So now we have to pretend that we're looking at f prime. Here's why it gets tricky. They're asking us questions about something. They're asking us questions about f, but we can't see f. So we have to use this translation. What I want you to do is write your reason first. So how do you guys know if f is increasing? We're looking at f prime, so I need you to write your reason in terms of f prime. Wouldn't it be where f prime is greater than 0? So let's go back and look at the graph. Where is this graph above the x-axis? Where is f prime greater than 0? -7 to -5, and then all of this. Now I get technically at this point right here, it's equal to 0, but that's okay, we can include it. So -7 to -5, and then -1 to 7. And the reason was because f prime was positive, so we need -7 to -5, and then -1 to 7. Okay, going on, when does f have a local min? Remember, we want to give our reason here in terms of f prime. It would be when f prime changes from what, guys? Local min. Isn't this a local min? So f prime went from negative to positive. So f prime changes from negative to positive. Okay, and to have a local min, remember, to be a local min, it must be a critical number, so it's where the derivative is 0 or doesn't exist. So we can go through and analyze when this derivative is 0. Here's a derivative is 0, because remember, this is the graph of f prime. Right here, what happens? F prime changes from positive to negative, and that's not what we wanted. Here's another 0. We wanted f prime to change from negative to positive. Here's our answer. This is going to be our local or our relative min. This one doesn't change sign at all, so we're just looking at -1. So f has a local min at x equals -1. Okay, concave up. Look at your graph. How do we know concave up if we're given f prime? If you remember, it's when f prime is increasing. This is the graph of f prime. Where is this increasing? It's increasing from -3 to 2 and from 5 to 7. Okay, let's go ahead and list that. So f is concave up. Go back and look at your graph if you need to. It was -3 to 2 and 5 to 7. How did we know? Because f prime is increasing. So -3 to 2 and 5 to 7. Looking at it again, -3 to 2 and 5 to 7. Okay, how do we have inflection points? Okay, inflection points, remember that's when the second derivative changes sign. That is like the easiest way to think about it. But we don't have access to the second derivative. So remember we are looking at the first derivative. And it's where the first derivative changes from increasing to decreasing or decreasing to increasing. So decreasing to increasing right here, or increasing to decreasing right here, or decreasing to increasing right here. Do you guys notice these are the local mins and maxes of the first derivative? Those will give us our inflection points. Okay, so we're at -3, 2, and 5. Let's write this out. F has inflection points. This is going to take a little bit. So F has inflection points when x equals -3 or 5 because f prime changes from decreasing to increasing. So we want to clarify the difference between increasing and decreasing or decreasing and increasing. We're also going to say f has an inflection point. Again, you guys can look back up at the graph to verify this. I already walked you through it. F has an inflection point when x equals 2 because f prime changes, this was the other one, from increasing to decreasing. Okay. Okay, knocked out that one. Now on to C. Instead of looking at f or f prime, you got it. Now we're going to be looking at f double prime. So now our reasons all have to include an f double prime. Well, how do you know concave down? So let's say f is concave down on, and we'll fill the interval in, because what's our reason? The second derivative is less than 0. Again, if you come up with your reason first, it tells you what to do. The second derivative less than 0. If this is the graph of the second derivative, when is this less than 0? Just right here, from -5 to -1. Okay, when do we have inflection points? Inflection points are when the second derivative changes sign. Remember when they asked us this up here, we gave a different reason. It was when f prime changed from decreasing to increasing or increasing to decreasing. We had the graph of f prime, so we had f prime as our answer. Now we have the graph of f double prime, so that has to be in our answer. This is the graph of f double prime. Where does this change sign? Changes sign at 1, 2, oh, not there, right? Just 2 spots. Okay, so f double prime changes sign at -5 and at -1. So let's go ahead and list that. F has an inflection point when x equals -5 because f double prime changes from, what did it change from at -5? I believe it was positive to negative. And then another one is f has an inflection point when x equals -1 because f double prime changes from negative to positive. Okay, so change sign, we listed the cases. Now we are done with that. Okay, the next thing I'm going to have you do is graph. So the graph below is of f. I'm asking you to graph f prime. Okay, remember when we did this, if we had f, the first thing we want to find are horizontal tangents, because if this is f, f prime is 0 here, f prime is 0 here, and f prime is 0 here. Okay, so we have those right away. That's good to know. Also, do you guys see over here, I'm going to use a different color, we have a vertical tangent. Remember the vertical tangent, the derivative does not exist there. And if I'm graphing the derivative cannot exist there. Okay, so we are going to be approaching this line. Okay, remember again, there's a vertical tangent here, and the slope of a vertical tangent doesn't exist. The derivative of a vertical tangent doesn't exist. You can see there's a vertical tangent there. So because of that, if I go to graph the derivative, there should be no value there. Okay, let's start over here. What is going on right here? This is the graph of f, right? What is f doing? F is decreasing, and because of that, f prime is negative, so f prime should be down here. Over here, f is increasing, so f prime is positive, and I should be right here. And also notice we had the 0 here, so it would make sense that we would go from here to here. Also something to note, look, f is concave up. Okay, if f is concave up, the second derivative is positive and f prime is increasing. So I need to start here, end here, and be increasing. So that is all making sense, and we'll do something like this. Remember, we want to not exist here, but get close to it. Okay, since we're on the left, let's just work, since we're on the right, let's work right to left. What's going on here? F is decreasing, which means, what does that mean? If f is decreasing, f prime is negative, and I should be down here, which makes sense on this piece because f prime is below the x-axis, and I'm also approaching this. So I'm thinking I'm doing something like this. Okay, on the next piece. Look at, I need to end up at 0 here, right? We can see from here to here, I go to 0. So let's say what's analyzing here, okay? I'm reading left to right. So if I read left to right, f is increasing. If f is increasing, f prime is positive. I'm graphing f prime needs to be above the x-axis. I need to be right here. I start at 0 and end at 0. Easy enough. Okay, going to the next chunk. Again, you guys, I started here because there was an asymptote because of the vertical tangent. You could have started on the left. That would have been okay. Okay, reading left to right. F is decreasing, so f prime is negative. Okay, looking at this whole thing, look at this whole thing, f is decreasing. Because f is decreasing on this whole thing, I need all of this to be below the x-axis. Let's kind of estimate some slopes. Look, right here at 0, then it goes to a little negative, then a bigger negative, then back to a little negative. So again, little negative, bigger negative, back to a little negative. I'm analyzing the slope. Okay, so maybe something like this. And please keep in mind, this is just a sketch. Okay, going on to the next one. You might need to rewatch that. I know that that gets a little confusing. Okay, the graph below is the graph of a function f prime. Okay, now this is changing. We have f prime, and they're asking us to graph f. I know the ordered pair here is at -7, 0. Okay, here I'm just going to read left to right. I don't see what we do. No, you know what? This isn't a vertical tangent here because this isn't the graph of f. Right? Even if there is one, if this is the graph of f prime, and if there's a vertical tangent here, doesn't mean the second derivative doesn't exist there, but we're not asked to graph the second derivative. We're asked to graph f. Okay, let's just go piece by piece. I'm going to take notes in black writing, and then I'll do the graph in pink. Okay, what happens on this first piece? If we're looking here, f prime is decreasing, and what else? F prime is decreasing, and f prime is positive because we're above the x-axis. What does that translate to us? F prime is decreasing means concave down. F prime is positive means increasing. So on this first region, I need to be increasing and concave down. Let's do this. Increasing and concave down. Okay, next region. If I'm right here, what's going on? F prime is still decreasing, but now f prime is negative. So I need to be concave down and decreasing between the next points. Concave down and decreasing. Concave down and decreasing. Okay, the next piece, I already wrote it in. F prime is increasing, but F prime is below the x-axis, so it's negative. So what does this mean? This means that I need to be concave up and decreasing to -1. So decreasing, I'll put a point here, concave up and decreasing. Okay, again, at this point we've done half. Why don't you try to do the second half on your own? What's going on here? F prime is increasing and F prime is above the x-axis, so F prime is positive. So this means I need to be concave up and increasing. Concave up and increasing, and it does it quite a bit, so I'll go up here, concave up and increasing. Okay, almost done. Right here, what's going on the next piece? We have F prime decreasing and F prime greater than 0. So this means that I need to be concave down and increasing. Concave down and increasing. Okay, a couple more. This piece, F prime is decreasing and F prime is above the x-axis. So what does that mean? I need to be concave down and increasing. Okay, so I already was concave down and increasing. I just have to go a little more. So concave down and increasing. Last one, F prime is increasing and F prime is above the x-axis. So I need to be concave up and increasing. And there we go. That is our sketch. This is an awesome way to practice drawing these, to go back over these, kids. You could pull the blank notes up and try it again if you'd like, or just copy it over on a piece of paper. Okay, you're gonna watch the last examples on day 2. See ya.